Yeah.
This meeting is being recorded.
Cool. Let's get started. So, once again, hello everyone. Very good morning. My name is Karthikeyan and your host today. So, for those who are new to the meetup, maybe a couple of sentence on who we are and what we do. So, this is Coimbatore Front-End User Group. It is a kind of a community-driven, mainly founded by Ramesh, Dinesh, and myself. So we have been running this for almost 2 years now. So predominantly, the mission of this group is, try to build a vibrant tech group so that we can learn from each other. We can contribute to the society in terms of uh, non-profit and learning and uplifting the community. So that is the primary goal. And so we have been organizing meetups month on month, mostly every month, so except Christmas holidays or Diwali holidays. So this month, with that note, this month we have Dinesh, one of our founding member of this community, is going to present Reactive Angular. This is going to be a almost hopefully three hours session. Hope you all enjoy. So before we jump into the session, I also would like to highlight a couple of things. And we have a warm sponsor, which is JetBrains, and we do have a sponsorship from them on licensings. So people, we usually run Rafael. In this time we'll see how we can do. So whoever needs any of their JetBrains product could be used for an year. So we have a set of licenses which can be distributed as a part of this meetup. So also, it has been 2+ years now, and we as a team, we have been trying to put this show together, and we are keep moving. And this time we would like others to also participate. If you would like to volunteer, all that you have to do is like, reach out to one of the admins. We have a Telegram group as well. So, or you can reach out to us in any of our social media, either Twitter or LinkedIn. So, yeah, with that note, I would like to let Dinesh take over the stage. Hi, Dinesh, welcome.
Thank you, Karthikeyan. Okay, so so I just want to point out it's like a fancy date today, right? So 22/1/22. Uh, so we are going to talk about this thing called reactive programming, right? In this session. So many of you may have already heard about reactive programming. It's not something new that just popped up. It's been there for almost like 5 to 6 years now. It started mostly coming up from the backend programming languages, or in designing systems, right? So reactive has been in existence for quite a long time, right? So but only recently a terminology, or the name was coined, and then principles around reactive, uh, around the term reactive started coming into play, right? And people started discussing about it and how to improve over it and what exactly is reactive and all this stuff. So if you see Angular, right? So Angular JS did not have reactive support by default, but uh, once Angular kicked in, right? So Angular 2, Angular version 2 and above. So it had RxJS as one of the foundational libraries for the framework, right? So RxJS has been in existence right from the day Angular was available for public use, right? And a few people, maybe using reactive programming with Angular, but you may not actually be realizing that you're using reactive, right? So in this session we'll not be going deep diving into many concepts. It will be more of an introductory session where we try to explore and understand all these technical things that are spoken about reactive programming, right? Because so far in in the past year or so, as I've been seeing a lot of people talking with a lot of young developers who are coming up in Angular and all, right? I noticed most people uh, don't know about Reactive. And another thing is, forget about Reactive, right? They don't know RxJS, right? They don't know RxJS as it's there in the package.json, right? If you see it, it's just a matter of going and Googling and finding out the website and exploring about it and getting to know what are the different functions or operators of RxJS you're already using in your application, right? But many people haven't taken the step to even, go to that, right? So when they don't know they're using RxJS, how can they leverage the advantages of reactive programming, right? So this is when I thought, I should be speaking more about this with a lot of young developers, and I have been speaking about it more or less on a person-to-person conversation, right? I've never actually thought of taking a session, but uh, the past couple of months I've been trying to make space to take a session around this so we can reach out to a larger audience, and mainly the young developers, right? People coming or just starting up with Angular, or people somewhere around less than 5 years of experience who are just starting to get the grip of Angular and trying to get into the professional Angular development circle. So I thought an exposure of this would really help people explore by themselves. So this session will mostly be about the basics of reactive programming and some uh, you know operators or concepts of RxJS. We will look at it from an overview. So this is to uh, get a handle on RxJS, right? We'll not be deep diving into anything. So with that out of the way, uh, about me. So my name is Dinesh Kumar. So I'm based out of Coimbatore in Tamil Nadu. So I'm currently engineering at TrustTrace. So if you haven't heard, TrustTrace is a traceability provider. So we strive to improve sustainability of brands by helping brands trace their products, right? So if you want to know more about TrustTrace, please feel free to Google, and you can also visit our website trusttrace.com. And I'm also a co-organizer at Coimbatore Frontend Group, which are over here. So hi to everyone from a co-organizer perspective. Okay, so coming to reactive programming, right? So if someone can say, right, because you may have already seen this, you may have Googled what is reactive programming before you RSVP into this session or something. So if someone can just unmute yourself and try to share your understanding of what is reactive programming. This is going to be an interactive session. You don't expect me to speak for all the 3 hours, okay? Okay, this is, should I take the silence? Yeah, someone's,
yes, Dinesh, this is Karthik.
okay.
From my understanding, reactive programming is comparing to the imperative programming. It is a way of doing the thing, means it is how to do a particular task. In reactive programming, we are saying what to do instead of how to do.
Okay, okay, okay. So instead of how to do, instead of how to do, we are saying what to do.
Yes.
Okay, okay, okay. We are getting somewhere. Anyone else wants to share? Okay. So the term reactive itself, right? We can, many of you all, as soon as you hear reactive, you'll automatically hear about proactive, right? So proactive is, you sort of try to predict something is going to happen and you prepare for it, right? Reactive is when something has happened and you're taking an action, right? So reactive programming is a concept wherein you react to events, right? So events, I think, are there everywhere, right? Whatever thing you're working with, there is always an event that takes place, and based on the event you perform something, right? So normally, if you see, as Kati mentioned, right, imperative programming. So reactive programming follows a declarative approach, right, rather than an imperative approach. An imperative approach is where you sort of have to know what is happening, and then you have to do whatever you want, right? But in order to know that the event happened, you have to keep sort of or you have to manually check for it, right? That is how we can put it. So if we come to uh, or putting up a definition, or before going to the definition, right, let me just explain these points I have over here. So reactive programming is a way of thinking, right? So for example, object oriented program, right? So if you take object oriented programming, it is not like some syntax or formulas that go into your code, right? It is just a set of principles that you follow, right, in order to solve your problem, whatever problem you have in front of you, how to solve that particular problem in a more efficient manner, right, in a more simplified manner. That is what OOPS helps you, right? It helps you build a more efficient solution around your problem. Reactive programming is similar to that, right? So like OOPS, when you say, so for example, if we take a group of animals, right, and different animals have different attributes. So how do we sort of create an application where we can handle the existing animals we have, and also if we want to extend new animals, or we want to add new categories of animals that come into the system, how do we do it, right? OOPS tells us over that, right? OOPS tells, you declare a base class animals, and then the animals has some base properties, and whatever animal, different types of animals come, you extend it and you add whatever extra properties you have, right? So this is just a way of thinking, right? You can actually handle it. I mean, the requirement which I'm saying, right? Having a group of animals, and you want to add it into a system and add different categories later, you can handle it even without OOPS, right? But OOPS just makes it much more easier, and on a longer term, when different people are working with that particular solution that has been defined, it makes it much more easier for those people to use that code, build up on the top of that solution, and then scale that solution as well. Reactive programming is something similar, right? It is just a way of thinking. But so far, all of us are used to that imperative approach, right? It would take or just in this couple of hours or 3 hours that we're going to have now, we'll not be able to immediately change our way of thinking over here, right? So what we'll do is we'll take a baby step, right? So this session would be a baby step to help us think reactively, right? So that we would be able to leverage the advantages of reactive programming and define, or say, create more concise solutions, right? So the common thing, or the common term that you would come across in reactive programming when you go and Google it, right, on wiki or any tutorial websites or any documentations or anything you go, one thing you would come across is asynchronous data streams, right? Reactive programming is programming with asynchronous data streams. So essentially, I think synchronous, asynchronous, since we are coming from the JavaScript world, we would already be aware of what is synchronous and asynchronous. Data streams are literally available everywhere, right? So you may not have realized it, but a simple click event that you're looking for the browser, right? So for example, you say document.onClick, right? So that is an event that is happening asynchronously, and it is a stream, right? So essentially what is happening is you wait for the user to click on something, and a data is generated out of that event, right? And that is pushed in a stream. So essentially what you do is, as a developer, you write a piece of code that is a function you pass to onClick that would react to that event, whatever happened. So essentially the user is going to click on the button and you want to say alert of hello world. You immediately say document.onClick is equal to your function. You receive the data, whatever you want, and you say console.log of hello world, right? So if you see this is happening asynchronously, this does not, block any other methods or anything that is going to execute. And at the same time, this is a stream of data that comes to you, right? So this is like one thing where, or to say, where we are already using asynchronous data streams in our day-to-day life, because I believe all of us are working with click events in Angular itself, right? So the native implementation of that comes from the browser itself is an asynchronous data stream. So if you take from the wiki, right? So what wiki says is reactive programming, RP, through most of the documents and very insightful articles that I read on a lot of places, reactive programming is commonly referred to as RP. You may come across FRP at a few places. FRP means functional reactive programming. There is slight difference between these two. But I leave that for you to go explore on yourself, right? But just so that you know these acronyms when you're going online and looking at it. So reactive programming is a declarative programming paradigm concerned with data streams and the propagation of change, right? So, when you immediately look at this, there may be a few things that are new over here. You may not be able to relate to certain things over here. What we'll do is we'll come back to this definition later, right? We'll actually go a bit more further in the slides and then we'll take a step back. So before I show this, so there is something known as Reactive Manifesto, right? So if I just pull in my browser over here and we go to Reactive Manifesto, right? So if you see, there is a website for this. All of us follow Agile. There is an Agile Manifesto. I hope many have visited that. So this is something similar to that, right? So there is a manifesto for reactive programming, and this basically describes reactive programming a bit more in depth, or the definition is explained, right? But again, if you see, there are a lot of jargons that are in this code, and sometimes you may be like, going down a rabbit hole just by reading these 3 paragraphs, right? Going after trying to understand term after term. But if you're able to get it, it's really good. It sort of exposes how much exposure you have in terms of the concepts, right? So if you see, the Reactive Manifesto covers certain things over here, right? So, but these are mostly towards, from a back-end approach, right? So if we go from a front-end approach, right, we can actually, put reactive development into these 3 things first, right? So how do we say, what do we mean by reactive development, right? So our application or our code should be able to quickly react to user interactions, right? So whenever a user is clicking on something, we should be able to, immediately give a response, or, tell the user something based on the event that happened, right? And the next thing is, our code should be resilient to failure. So resilience to failure is error handling, right? It's just a synonym for error handling. So example, right? So an event occurs, but there is, some failure. The event failed for some reason, right? So you're going to get an error message. How are you going to handle it? How are you going to show it to the user, right? So an application, it's never about an application breaking down. It is about how you communicate with your user about what happened and how they can rectify it, helping the user, right? Your application should be more or less a guide to the user to use your application, right? Your code should not just be the functional aspect of it. It should also ensure it is being a guide to, walk your user through all parts of the application. So that is resilience to failure. And then reactive to state changes, right? So your code should constantly be, looking for state changes. So if something is changed, it should immediately react to it rather than, procedurally checking for changes on a routine basis or something like that. So to give you one example, right? Take user login. So let's just say in today's applications that we build, right? We have so many components, right? Like numerous amount of components that come in to build one single page, right? It is no longer like the olden days where, the one HTML page that loaded, it has the CSS, it has the JavaScript, it has the HTML and all this stuff, right? We have literally, modules and components that we build, and we lazy load them into the application, and different components need to speak to each other to, sort of give that user the experience that we want them to experience on the application. So essentially, a simple thing as a user login, right? So that is a state that you maintain. As is the user logged into the application or not, right? So consider the user is logged in, and now the user goes and clicks log out. So now you would have to, sort of communicate to all your components, telling the user is logged out, right? So the state changes happen. So all the components can, literally flush out their data. They can, the router can redirect the user to the login page and all this stuff that needs to happen. So there are different ways of handling this, right? But what Reactive says is we should not actually be, procedurally checking if the user is logged in or not, or, or keeping on checking the login state. Rather, when the login state changes, an event should be triggered from that. And essentially, the other components should be listening to that event, right? They shouldn't be checking for the event. They should be listening for the event, right? So once they receive the event, they can automatically perform the operation, whatever they have to do when a user has logged out, right? Similarly, you can take that for login as well, right? When a user logs in, so the router receives the event that, hey, look, this guy is already logged in and this is his token. Okay, the router, pushes him to the dashboard page. Then the dashboard components kick in. There are widgets on the dashboard page. The widgets automatically fire the API. They give the token. I mean, this and all should be reactive, right? The dashboard shouldn't be like, is the user logged in? Is the user logged in? It shouldn't be like trying to procedurally check. Or when I say procedurally, you don't keep on be like, calling a function to check if the state has changed from the dashboard. Rather, the dashboard should be neutral to this, right? It should not have any dependency on that. It should rather just be listening, right? If an event changes, an information comes to the dashboard, and based on that, the dashboard reacts. Fine. So, so far we talked about this reactive development, but we talked about this thing called data streams, right? Oh, sorry about this. I forgot to remove this from the template, so please ignore this. So when we take reactive programming and the definition we saw, streams, right? So streams is one of the primary aspects of reactive programming, right? Because when we come to computers, everything is data, right? So, and for us in reactive programming, the data travels in a stream, right? So streams is a very primary aspect of reactive programming. And I put in these two pictures over here just to visualize, right? So as soon as I say stream, you may probably be imagining like, a stream of water, like in the picture on the left, that is just flowing through. But the thing is, data cannot always be flowing, right? So data is more like, what to say? It is not like a constant continuous flow, right? So data is created, or data is sent out only when a particular event or something happens. So you can actually consider stream to be something like, what do we call this? I got stuck with the term over here. Conveyor belt, right? So if you see, you can consider streams to be something like a conveyor belt, right? And if you see the packages over here, so these are the data, right? So, I mean, it is a bit consistent in this image, but just consider, right? There may be one package, there may be a meter gap, and then there may be another package, and then no packages for 10 meters, and then another package comes in. It will be inconsistent with this, right? So as and when events occur, a data is pushed into the stream that is on the conveyor belt, and then the data is processed or it's given to the the next process, whatever needs to be handled. We look more into this as we go, right? But I just wanted to get this visualization in front of you, so that every time you think of a stream, you think of your data moving on a conveyor belt, right? So yeah, we've actually covered up to streams now. So before we actually move on to the next, right, I just wanted to ask if there's any questions, or there is something you don't understand that we can talk about more in detail at this moment. You can feel free to ask, or even if you have something different from my perspective over here, or if you think something can be explained in a much more simpler view, please feel free to step in. I would really love to hear.
Hi, Dinesh. Uh, uh, Actually, I'm new to this reactive programming. Can you give me some visuals like in Amazon.com or Flipkart, how the reactive program is used in any website where you can show me any visual?
Sure. Oh, did this actually come on Zoom or? Okay. So let's just take one, right? Just bring up my browser and let's see. Okay, let's go to Amazon itself. Okay, so I'm logged into my account over here, and if you see, my cart is currently empty, right? And this cart itself is a separate component over here, right? So it needs to connect with a lot of different components on the application in order to understand what number it should be shown over here, right? So for example, let me just go to some product. So let me just go to this headset over here, right? So if I come to this headset, and let's just say now I click on the add to cart button, right? So essentially what would happen? This would in turn fire an event from, okay, this literally took me asynchronously. I mean, this took me synchronously, but just consider this, right? So let me actually come to my cart. Okay, so actually this works. Let's take this example. So I'm adding this to my cart, right? So now it is, I'm in my cart page, right? So let me just add a few other things. Sorry if you're seeing a lot of kids stuff over here. So let's just come back. Let's go back. Put some more products with those deals. So let me just open this. Okay. Okay, so now if you see, I don't have anything on here. Let me refresh this page. So if you see, I have 3 items in the cart, right? So on this page, this shopping cart is a component for me. This cart is a separate component for me. This subtotal and all this stuff that is showing over here, this is a totally different component. So if you see, when an action happens on one component, right, I would have to ensure these things are also updated, right? So for example, I'm deleting this. I don't want to purchase this, right? So if you see, automatically my subtotal has adjusted, and also my cart component has adjusted accordingly, right? So this is what, or this is one of the examples of being reactive, right? So one event occurred over here. So what I am doing is, I mean, this could probably be handled in a different way as well, right? But by the current, reactive methodologies that are being adopted by most of, I'm not saying Amazon is definitely adopting a reactive pattern over here, but this is where reactive actually comes into play, right? So one way I could handle this one is, I could keep on be sort of polling the API over here, right? So I could be polling my cart API in the subtotal. This also I could be polling the cart API, and this one, this also I could be, once I click on the delete button, I'm re-rendering the cart API. This is also calling the cart API again. So if you see, if I'm taking that pattern, then essentially this is like, a pull approach for me, wherein I'm keeping on polling to check if there is any update and I'm updating. But when it comes to reactive, right, you don't do that. What you essentially do is you look for one source of data. So essentially, whenever the cart is updated, that event is automatically passed to the cart component and the subtotal component. So essentially, based on the data it receives, it is going to update it. It is not going to be, keeping on asking for data by itself. It is just going to stay as a listener, right? It is never going to go and say, hey, cart, has anything updated every 10 seconds, right? It's not, or every second, it's not going to go and say, hey, cart API, has the user made any changes? Hey, cart API, has the user made any changes? That's not going to happen. So what is going to happen is, whenever a user make changes in the shopping cart will say, hey, cart component, hey, subtotal component, look, the user has added something to the cart. You do whatever you have to do for, rendering your details, and cart component, you do whatever you have to do. This is what reactive programming does, right? So I hope this makes a bit of sense in what we are talking about when we say reactive.
Yeah, yes. Understand.
Okay. So as I said, so reactive programming is a way of thinking, right? So it is not that you have to use reactive in order to get something done. You can actually use something else. But if you see the amount of code or the amount of, or the solution itself is a bit complicated when you have to design things to pull data, right? But rather what reactive programming focuses on is to push data, right? Rather than every component pulling for data, wherever the event originates, it pushes the data, right? So that the other people can just sit and listen. They don't have to, keep on be repetitively pulling for data. They can just sit and listen. Once the data is pushed to them, they can react accordingly, right? Take this as a tantamount to a person itself, right? So consider you told someone that, you'll get something done in some amount of time, right? Or okay, that would become like a finite number. Just say there is no amount of time. You told them you will get this done. But that person keeps on coming and asking you, is it done? Is it done? Is it done? Right? So this is what we say as, a normal or a traditional way of us handling the events up to now, right? So rather than the event coming to you, you go to the event. You keep asking, is it done? But rather take that person, whoever, is, or you, whoever is, you who has committed to do that thing. Once it is done, you go and tell that person, hey, see, this is done. And this is the result of whatever was done. You do whatever you want with it now, right? So this is what we're talking about reactive. Rather than a person keeping on requesting for something, once the thing is done, you push it to them. That is all. So I close this for now. Anyone has anything else? Okay, yeah. So we'll move on to the next. So just a disclaimer. I did mention this session may be a sleeping pill for some. So the reason is because I'm just going to, try to check and see if everyone is grasping the concept, and to ensure I'm able to give different perspective of examples to understand reactive programming, right? Because one explanation may be good for someone and someone else may not have understood it, but it is really helpful when, if you don't understand it, when you raise a question or you say that you don't understand, so I'll be able to put in different examples that you maybe relate to in in your day-to-day life. You may be using whatever the example I'm putting forward, right? So you may be able to get a grasp of it, and it is very important you get a grasp of this base idea of reactive programming, because it is a way of thinking, right? It is how you think. Reactive programming is not a set of syntaxes that you can just read and you can just sort of, I mean, you can learn and you can sort of just start coding with it, right? Reactive programming is a way of thinking. You should be able to think reactively in order to be able to program reactively, right? You have to change your perspective over here from a normal approach to a reactive approach. So please feel free to push in as many questions. If you don't understand something, just push it out, right? I myself, I'm just exploring and learning a lot of things in reactive, and every day there is a new thing that comes up, right? So don't hesitate to ask questions. We have plentiful amount of time, so just feel free to open up. So this is an interesting thing, right? So now what we are doing is we are actually breaking down the stream into different things that we will see on a regular basis, right? Any stream you take, these are some things that will be there. And streams are generally represented like this when you write it. When you don't code but you want to represent it on paper, it is represented by like this arrow mark with small bubbles on it. But this is actually called a marble diagram, right? So, and we'll consider these as marbles, right? These small circles are marbles. So as I said, this particular thing should have actually come on the previous slide. Streams are central to Reactive. So streams, as I said, are the very core things of reactive programming, right? So let's actually break this down. So if you take the straight line, the arrow mark that is going over here, right? We'll take this as the timeline, right? So in that timeline, these marbles are events or data that is being pushed, right? So these are essentially going to travel, or they're going to occur in a sequence on the timeline, right? So at whichever point they were triggered, or whichever the point they were laid out on the stream, they're just going to come on this. So this timeline is the stream, right? So, and these are the data that are traveling on the stream. So essentially what will happen is there are different things that can happen in a stream, right? So one is you can get a value in a stream, right? So that I represented over here. And another thing is an error can occur on the stream. So an error is something that also happens on the stream. And another thing is the stream is completed, right? It is done whatever it has to do, and the stream is finished. This straight line or this pipe symbol, it indicates that the stream is complete, right? So this is the base representation of a marble diagram, and these are the things that you normally come across when you see a marble diagram. So it may be a bit confusing. Rather than seeing the marble diagram, I just want you to remember these specific things that are involved in a marble diagram, right? A value, an error, and a complete sequence, right? Or in a stream. So if you have any questions or anything, just feel free to raise your hands. I don't want to repetitively ask if there is any questions. Just unmute yourself and fire away the question, right? I'll stop as soon as someone unmutes. Okay. So if you see, yeah, someone's unmuted. Okay, I think it is done mistakenly. Let's move forward. So streams solve problems that are basically surrounding data, right? So sending data, receiving data, and processing data, right? So this should be straightforward, but just to say, if you look intensely or to the base thing of reactive programming, right? The only thing or the main thing we are talking about is how data flows. That is all, right? So if you take the approach that I mentioned in terms of a person, saying he'll get something done, another person coming and keeping on asking repetitively, is it done? Is it done? Is it done? This is basically data flow, right? This person says he's doing something and he'll get it done, and the other person needs data, right? So is it done or not? Is it done or not? He wants to know. So essentially, if you see, one way of this is this the other person coming and keeping on repetitively asking, is it done? Once it is done, he grabs the data and then he processes it. But in reactive, we are just changing the data flow, right? Rather than the other person coming and keeping on repetitively asking, we are just pushing the data, right? So the way we are sending data, the way we are receiving data, and the way we are processing also changes over here. So essentially, if you see, at the core part, reactive programming, deals with streams, and streams mainly solve the problem of data, right? The way we are sending a data, the way we are receiving a data, and the way we are processing a set of data. So I think this is something we already talked about, right? So what streams provide is a change of perspective, right? Instead of asking for data, you're telling everyone to listen for data, right? Keep on nudging for data, right? Don't nudge me, please. Once it's done, I'll let you know. And this is what reactive says, right? So just listen for the data. Don't keep on pestering me, asking, is it done? Is it done? Is it done? Don't do that, right? Once it's done, I'll give it to you. Just, once, then you can react to the data, whichever you get, right? So this is what streams provide, right? In general, is someone not able to get this perspective? It is very important that we understand this perspective, right? And we hard code this in our mind every time we think reactive, right? So when it comes to reactive, we do not ask for data, we listen for data. Every component we design, we create, we code, we should always have in mind the component should listen for data. The component should never ask for data, right? So if anybody has any confusions, or if you didn't get this perspective of streams, or this change of perspective that streams is bringing to the table, we can have a much more detailed discussion on this. Or if everyone got it, okay, we'll just take a 5-second. Yeah.
Yes. Can you hear me?
Yeah, I can hear you. Please go ahead.
Yeah, I just need a clarification. Like, for example, I'm a React developer actually. So
Okay.
you were saying like it has to listen the data. And could you please explain detail about how it has to be listen the data means?
Okay. So let's, as I said previously, right? So let's take a simple example over here.
Okay.
Let's bring in this, and let me open my console. Let's actually open something. I don't think you need to open an app, so I'm just opening it for the sake of it. So make it bigger. Okay. And this is big enough. So let's just do one thing. So right. So I have the document over here, and I'm saying document dot one click is equal to, and I have a function, right? So, and here I'm saying, just say console.log click. Okay. So this is a simple, event listener I created. Am I correct?
Yes.
Right. So what is happening
yes.
is, every time a click event happens on the document, this function or this, I mean, the entire thing is called name, but this function is what is going to react to that event. Am I correct?
Yes, yes.
So essentially, we have created an event listener over here. So instead of, every time, this is not going to be keeping on checking if the user has clicked, if the user has clicked, right? It's
Yes.
just listening. It is passively just staying and it's listening, right? So when I click on, it says click,
Yes.
right? So this is what we mean by listening to events rather than pulling for events, right? So one thing I said about pulling for events is you can take polling, right? So when you're going to be polling an API to, check if you received something, right? I mean, polling, yeah, but then that would come into reactive systems also. Take something else. So let's just say polling is fine. I don't think we can overcome that with reactive programming on the front end. But let's just say once a data changes on one component, the other components that are dependent on it need to also change, right? But
Yes.
these components, how do they know the data changed? So essentially, they may be repetitively checking if this thing changed. Am I correct?
Yes.
This is what I'm saying should not happen. So rather, what should happen is once component A makes a change, it should automatically propagate to component B and C saying, look, this set of data changed, you do whatever you have to do.
Okay. Okay.
I think okay, I'm not sure why this emoji is coming up, but yeah, cool. But I think as we jumped into a bit of code, I think you may understand it or you may get a better picture of it. Okay. Okay. So, okay. So I got this example set of things that I took from another article, right? And this was really interesting. So I just wanted to put this over here and discuss it over here in the session. So if you take modern web apps, as I said previously, right? So modern applications that we are building, right? It can be mobile, it can be web or whatever, right? They are extremely complex nowadays, right? So if you see previously, like front end was not even a thing, right? You are a programmer, right? Or you are a developer. That is it. You're a web developer. You're a web developer means you know some backend language, you know how to deal with HTML, CSS, and JavaScript, and you're more like that full stack thing was called web development. That is all. There was no backend, there was no front end or anything, right? You learn both. That was the thing. But now, if you see, I mean, front end has diverged into its own exclusivity, right? It has a premium privilege of front end, right? So the reason is the amount of moving parts that have come into front end, or just to the things running on the browser, right? So if you see, there are so many components that stitch together to enable rendering one single page for the user, right? So if you see, when multiple components like this, right, work together, there are various things that have to happen, right? So like they have to request data from various sources, right? So they have to transform the data that they receive and they have to, then render it to the user. Then there may be instances where you will have to take two different data sets, combine the data sets, and then render it to the user, right? So this could be coming from anywhere. Then putting the data on the screen for the users. That is the final part. That is the, if everything goes according to plan, right? You get the data, there's no error, there's no, unforeseen network errors, or the data center did not go down in a fire. Then you're able to render whatever the information you have to the user. So, and when we say data source, right, we just don't mean the API. there are different other data source that are available now, right? So there are WebSockets that you may have to listen to. There are user input events. Is the user clicking? Is the user hovering, right? So is the user focusing on an input field and all this stuff? And then there are input from sensors. So when I say input from sensors, this is basically coming to mobile, right? So if the user is in a landscape mode or is in a portrait mode, based on that, you would have to change your application to behave in a certain way. And then communication from webworkers, iframes, or any other relevant windows or child windows that you have in your application. And then comes local storage, right? So if you're storing your tokens in local storage, or if you have some other data that you're storing in your local storage, or you may be even using IndexDB. So if something goes on over there, if something changes, then that is also a data source that you're reading data from, and you need to react accordingly, or you need to do something about it. So with so much of things, just we are just talking about data over here, right? We are not talking about any other aspects, just data. So if you see, I may have left out something over here, but if there is something left out, please feel free to add. But if you come to scenarios, right? So on on a daily basis, based on these things that we saw, right? These activities that the component have to perform, there are a lot of problems we ourselves will come across as front-end developers, right? So a few things I've just added. So we have like around 3 or 4 things over here. So one is, a single data source is used simultaneously by several independent components. So that is the Amazon example we saw itself, right? So essentially the shopping cart component depends on the cart API. The cart component on the top right that just shows the number of items in your cart depends on the cart API. And then the subtotal that also depends on your cart API, right? For it to know how many number of things are there in your cart and what is the price of each. So essentially, if you see, this is an example of how several components depend on one data source, right, to provide different kind of data to the user, right, on a single page. So then a component needs to listen for updates from its data sources and react to them in real time, right? So this is basically like a monitoring page you may have for your application, showing how many users, an analytics page maybe showing how many users are online at the moment, how many users on a certain page, and all this stuff. So if you have things like this, right, you may be constantly hitting your API, and you may be constantly changing different components, right, or even the same component, right, but in real time, right? So you may be using a WebSocket over here, or you may be using a polling, or you may be polling an API to get this done, but whatever, right? But this is also one thing that you do on a daily basis as well, or maybe maybe a few of you don't do this on a daily basis, but this is also a scenario that most of us have to do on a daily basis as well. So several independent parts of an application need to be kept in sync, right? So this is again in term related to the first one, right? So essentially, if you see, taking the shopping cart again, the shopping cart, the cart, the number of items in your cart component, and then the subtotal component, all these things need to be kept in sync as well, right? If one event occurs on the shopping cart component, that needs to be reflected on the subtotal and the cart component as well, right? So essentially, if you see, anything happens in the cart API, or new information comes from the cart API, they should be reflected in all places as quickly as possible, right? So if you take in the olden days, or I'm not sure if it still happens, but there were websites where you go and you edit your profile, right? So you change your name, and you click save. That may be an asynchronous. The form may be submitted asynchronously, and it'll say your profile has been updated. But let's just say, for the sake of our example, your username or your name is also displayed at the top right corner where your account details are accessible, right? If you notice, that would not be updated until you refresh the page, right? So these are some places, where we say this, right? Maybe even if we take Amazon, and if we go, a decade back or so. That was the case in Amazon. But basically, Amazon, what they would have done is, rather than providing asynchronous and having inconsistent data on the page, they would be refreshing the entire page, right? So this, if you see again, it makes the user experience less intuitive. It also takes a lot of data from the user, right? So these are some things reactive programming tackles with over here as well. So now we are in the era of sparse, right? So this is something we have to be very keen on. How do we keep all the components that get its data from a single source synced together, right? Any update occurs at the source. How do we ensure all the components get the update, and how do they all stay synced? Then the next one is user actions in one component should update several other independent components, so that the one component acts as the data source for this. So this you can literally take as the login, right? So essentially, so when you go and you log in, probably your auth component is going to be handling your login state. So essentially what would happen is your auth component is responsible for every other component to know if the user is logged in or not, right? So and this also depends on a user action. The user decides if he's going to log in or not, and if he decides to log in, that is a user action. So essentially, when a user performs that action, the auth component is responsible for ensuring every other component knows as the user logged in or not, right? So this is just a common thing. So every one of us over here would have created a login system, right? So essentially, this is something that we can relate to easily. So this is something you may not face on a daily basis. The reason may be because you're negotiating with your backend developer to sort of fit everything into one API and give it to you, so that you don't have to deal with the mess of things in the front end. But if you're actually to follow proper REST principles and all this stuff, your developer may be, or your backend or your API developer may be saying, no, I can't do it. This is how it is. You deal with however you have to deal with it, right? So and there may be cases where you have to take two data from unrelated sources, unrelated APIs, and you have to merge them to show something, right? So one example you can take is let me think. Let's just say I want to take the time, right? And I want to merge it with I'm not able to get something good over here. Okay, let's just say we are taking different time time zones, right? We are having one API that gives us different time zones mapped to another time zone, right? So if we basically say pass a time zone parameter, say IST, so IST with every other time zone we get a list of that, right? And we have another thing that shows us a user activity list, another API that is coming from another system. And what we need to do is, based on the user's current time zone, we need to just map this and show it accordingly. I mean, this is not a very good example, but just take it for the case of this, right? So these are also some things we have to perform on a day-to-day basis as well, right? Mapping or merging two different data sources to show a meaningful data for the user, right? So when it comes to these things, right, you will have to perform some complex processing as well, right? You will have to transform the data into something, then you may have to merge the data, or you may need to split the data, and all this stuff happens. But the main thing lies over here, right? So this transformation and merging and massaging of data, whatever you're doing, this needs to happen every time the source is updated, right? So if you see, when I say this, right, just don't look at it as one component. This has to happen for all the components. This data needs to be synced to it, right? So essentially, if you see, when we start looking at maintaining the sync between different components, this automatically starts becoming complex, right? How am I going to do that? How am I going to ensure there is only one place where I get the data source? I deal with the data and then I supply it to every other components, right? So these are some, problems that we face on a day-to-day basis, and reactive programming helps us define more simpler and concise solutions for these problems, right? So how many of you are actually able to what to say, relate to these problems? Or if you want to add any problems to already those that specified over here, right, you can feel free to add as well. And if you relate to it, you can just tell your experience or any frustration that this problem causes for you.
Yeah, if you don't mind, shall I can share my experience?
Yeah, please go ahead.
Yesterday I think I have faced this problem actually. Like for example, we use Formic for our state management.
Okay.
Formic library. So, for example, there is a filter on the left side.
Okay.
There is a filters on the left side for filtering a data. So while the user clicks on any filter values, we have to redirect to the different route actually.
Okay.
So we have to trigger an API for it, and then we have to when they click on it, we have to redirect the user to the some other route actually. So that was a use case. So the formic values are maintained in a different component actually, and the API calls are also maintained in that same component. So whenever the user clicks on that checkbox kind of a thing, so the state value is changed. So the API call is also triggered. So this was a use case, and but what is the problem in sense? When user clicks on it, when the value changes, when we try to redirect, like it doesn't redirect. We have
Okay.
to think of different solution for this. So I don't know. I was keep on thinking of it, and one of my colleague who's working with me is told like just maintain a separate value while at the initial load. Okay, when the page is loaded, we are maintaining a state value like boolean, some kind of a boolean for a reference.
Okay.
By default, it is set as true. So what in sense, whenever the value is changed for that filter, then only the API has to be hit. What is the problem was while at the initial load itself, that API filter the API is also called. It should not happen.
Okay.
Do you understand what I'm saying?
Yeah, I think I got a gist of it. I couldn't completely.
Okay, I'll tell once again.
Yeah.
While the website is loaded, that's a homepage actually. While the API is while the homepage is loaded, the filter has a separate API call.
Okay.
So while at the initial load itself it is called, it should not happen at the initial load. Whenever the value is clicked on the filter values only, it has to call.
Okay.
So that was a problem. So for this, we have handled in a different way. Like whenever while we maintain a separate state for this initial load. For example, it is set to it is true initially.
Okay.
So while the initial load, that API where we do that API call whenever the values change. So at the initial load, we set to false.
Okay.
So above the API call, we have set it in case if it becomes true only, this API call has to be rendered. Otherwise, till that it should not render.
Okay. Okay.
So that's a use case. And after that, when it is loaded, when it is initially loaded, we set it as in true once again.
Okay. So the next time the user clicks on it, then can load as well.
Yeah. When it is clicked, it will be automatically redirected.
Okay. Oh, fine. Got it. Okay.
So that was a use. That was a use case. But actually, the second parameter for the use effect, which was passed like in formic.values. Whenever the values change, the API call is done, and whenever the values change in the formic for that filter, the API call is also done. so that the API call is done. Likewise, there was a like whenever use effect, whenever the values change, API call will be done. Likewise, that was a that was thing is used in that use effect actually. So
Okay.
that's how we handled this scenario. Actually, it was a mess actually. This may help whenever for filters. This would help someone, so that I just
Okay.
experienced.
Okay. Hopefully, after this session, maybe you can try to take, you can try to take a stab at the problem again using a reactive approach. Maybe that will help you, make the solution more simpler. That is all.
Yeah, that's
So essentially, the goal is, uh, when another person is coming and looking at your code, right? So as a developer, there are a lot of memes around this. So whenever we code, we should ensure the next person who comes and sees our code does not wants to come searching for us with a knife, right? So yavanda in the code எழுதுனது அப்படினு தேடி போறப்ப. So in that thing, right? So what Reactive will do is it will enable us to provide more simpler solutions that will also help us share knowledge easily of the code, right? So yeah, so thank you, Murgesh, for sharing your experience with this or around this problem.
sorry.
No, thank you for sharing your experience.
Yeah, that's what that was a mess which I found it, and I could not figure it out actually, and I never seen this kind of a problem. We used to maintain a search filter, values and all would be handling in the same page. So this was the first case where we came across we have to redirect to some other page. So that's how uh, so kind of this kind of a problem can be what would be a solution for this? Can you please tell me?
Yeah, so that is what I said, right? We'll actually go through this. So rather than me, I don't want to turn this into a problem solution discussion. So what we'll do is we'll go through the session. You take a stab at the problem with the reactive approach after the session, right? So also ping me. Are you on the channel? We have a Telegram group. You can just directly ping me. You can also DM me on Telegram. I'll be happy to connect with you.
Yeah, sure. Thank you. I will. Can I have a link so that I think I don't have a link.
Karthi would share it on the chat, Zoom chat.
Okay, sure. I will.
Yeah, thank you.
Thank you. Thank you.
So, thank you, Murgesh.
Thank you.
Anybody has any other experiences you want to share around the problems you face on a day-to-day basis with data, right? Dealing with data, dealing with multiple components, APIs, syncing data between different components.
Yes, Dinesh. Karthik here.
Yes, Karthik.
Let me share a link in the chat. Can you open this link and share?
Yeah, sure, definitely. Yep.
Yes, Dinesh. Actually, I faced a scenario like when the user types value in the input box. When each key of event, we need to trigger an API call. So
Okay.
whenever the user types some keys, for example, A, B, C, D, for each key of we will trigger API call. Which is unnecessary. We will trigger unnecessary API calls, right? So to optimize this action in a reactive way, I found this article was very useful. So can you please scroll down? Yeah.
You want me to go down more?
Little bit up. Okay. Here, whenever the user types the keys, here in console, we see the value.
Okay.
So on one each key up, we are going to trigger API call.
Okay.
Okay. So in reactive way, we create an observable for that input element. You can see on the top of the code section. Yes, right.
Yeah.
Yeah. Whenever the user types an input, the observable will automatically get subscribed and display it on the console. So can you please scroll down? Yeah. With using of the debounce time, it is an RSAS operator. When the user types continuously, after the 500 milliseconds only, the API call will get triggered. So we can avoid the API calls whenever we are inputting each character.
Okay.
This is one of the feature, and another operator is like the distinct until change. So below that.
Okay.
This is this will avoid triggering API call with the previous value. If the API call triggered with the word called Dan, once the user type Danny, and then again they erase the values like NY. Again, the value becomes Dan. So it is the same as the previous value. So the API will not get triggered.
Okay. Okay. This is really great. I think this is something that we usually come across, because there is a lot of type ahead input boxes that we have nowadays, right? So as we type, we get data from the API and we show. So I think this is a really great thing that you pointed out, Karthik. Awesome. We'll also see how this works, right? So how the debounce time actually works. We'll just see it as we go, a bit deeper into the session today.
Sure.
Awesome. Thank you, Karthik. Anybody else has anything else to share? No? Okay, so we'll move on to the next. So it's been nearly an hour or an hour and 15 minutes. So if we need to take a break, we can take a break, or we'll just take 2 minutes. If you need to get water, if you need to go to the restroom or anything, let's just take a 2-minute short break, and then we can come back. So
maybe it's a halfway break. Can we plan? So everyone we can connect by 11:30. So just 1.5 hours. So we'll be completing. So after that, from 11:30, we'll just have the stretch continuous session till 1. Is that will be fine, guys?
Yeah, that would be fine for me as
well. Sure. Then, yeah. So, guys, maybe we can just discuss. But meanwhile, guys can also just to introduce yourself, or just discuss with the guys who are available online. So just to make use of the time. Okay, guys. Yeah. The guys want break. Maybe you guys can move on. So. Otherwise, who are on break, not require break, maybe you guys can just stay here.
Okay, I'll be back online in 2 minutes.
Sure.
So, yeah.
So, yeah, the guys who are staying online. So, yeah, if any one of you have interest in volunteering, so you can just if you have any need any clarification on that, we can discuss here. Whoever interested in volunteering.
Yeah, I would like. Can you please share me that Telegram link so that I can join in the
Yeah, just a second. I will. Okay, I just put our Telegram group in the chat. So if you guys not joined, kindly join. So here, guys will be sharing some useful resources, or if you have any kind of support or direction need in your project, maybe you can just put on your question here. So someone in the group will try to answer.
Thank you. Thank you.
I'm back. So if anybody is online.
Yes, Denise, I think we just asked the guys anyone interested in volunteering. So I think guys, most of the guys move away. So.
Okay, Ramesh.
Hi, Dinesh.
Hi, Shravan.
Yeah. So I'm just having one doubt that I'm completely having a background of .NET development.
Okay.
So is it too late for for starting the reactive programming? This is completely new to me.
Okay. So it's never late, or it's better late than never. So
Yeah,
that is something I totally believe in. So what I would, or even, sorry, let me just reframe my question. So you said you're coming from .NET background, right?
Yes, yes.
So do you want to learn reactive in JavaScript, or do you want to focus more on .NET itself, or how to reactively program in .NET?
To be frankly speaking, I'm not completely aware of where to start and how to proceed with that. That itself, this is whatever you are explaining is really awesome. So I'm really understanding the concept of what is reactive. This is really this basic. Really, it will be helpful. But I'm not sure. Frankly speaking, I'm not sure how to start and where to proceed. Whether in the .NET itself, reactive tools are available for development, or completely moving into that other languages, no, like JavaScript or other tools to do the development activity.
Okay, so
frankly speaking, I'm not no
got
having
it.
idea. Yeah.
So since you have a background in .NET, I would suggest you start with .NET itself, right?
Yeah, thanks.
So if you actually come to this website named reactivex.io, right? So RxJS is
Reactive.
reactivex.io. I shared it in the chat.
Yeah.
Oh,
Thanks.
sorry. I think I sent it.
That's the
Yeah.
screen share. Hope the screen is visible to you.
Yeah. Thanks. It's visible. Yeah. Thanks.
So if you see that website, right, and if you come to languages, you can see there is something known as rx.net over here itself. So if you go over there, you would have details of how to set up this reactive library for your .NET project, whichever you're working on. So I am not very familiar with using this library in .NET. So currently I am looking at only JavaScript, right? So what I would say is you can actually explore on this, and the concept so far, if you see the concept I have been explaining so far is generic, right? I haven't even come to Angular yet, right?
Yes.
So as I said, we are going to be looking at very minimal amount of code or in-depth content in this session. So my primary thing is to enable you to think reactively. That is all. The only purpose of this session is to, at the end of the session, when you step away, when you're looking at your code again, right? When you're creating a component or when you're creating a system with different APIs and all this stuff, you should think reactively, right? Apart from thinking the regular pull type of methodology that we have been following so far, you should also be aware of a push methodology that is available. So there are some places where pull makes sense, right? So we shouldn't go and be reactive everywhere, right? There are certain places it is fine. Pull works best. Let's just have it that way, right? But there are certain places where push would make our life easier, right? So push methodology. So yeah, I think that is the purpose of this session. So it will definitely be useful for you if you even have to go and take up rx.net and move forward. But the resources I may not be able to point to you. The reason is because I haven't looked into rx.net so far. So you can actually take a look into the resources by yourself, and they already have a tutorial section over here. So
Sure.
if you see, there may be an rx.net recommendation over here itself. So there's rx, or there is over here. So if you see, there are already a list of tutorials that they have recommended. You can actually go through this itself. This itself would be very helpful for you to take a first step in reactive programming in that.
Sure. Thanks. But normally, how the industry, how the reactive programming is being used? What are the kind of tools being used? Maybe in case of if I am not disturbing the session, maybe I'll take it offline. No issue. I thought of asking since it's a break time.
Yeah. We still have a few seconds. So if you see reactive programming, if you just see the amount of languages that these guys have created the library around, right? So you can see how much of adoption is there for this concept as well, right? So as I said, this is not a new concept, right? So it has just become a separate branch of its own now, considering the complexity of the systems that are coming up as we step upward in technology, right? So as I said, even front end and back end wasn't a thing a decade back, right? So
Correct.
only after Angular JS came, right, it redefined front end, right? Until then, every backend developer knew jQuery. Every backend developer knew HTML, CSS. So as I said, they were just a web developer. There was no like, nobody called a jQuery developer or something like that. But now if you see, we have Angular developer, we have React developer, we have Vue developer, we have whatnot, right? So I'm just telling the prominent things. But then if you see, there are front end has just become a very wide thing. So similarly, this reactive concept as well. Reactive concept has been in existence for quite a long time, but the need for reactive has increased with the complexity of the systems we are building, right? So that is why reactive became a separate fork of its own, and it is being, focused on, it is being studied, researched more keenly, and seeing how we can, leverage reactive to a much more broader scope, so that we can make the system we design much more simpler.
Yeah, thanks. It's really helps me to understand. Yeah, thanks.
Thank you, Stan. So I hope everyone is back. Yeah. So can we resume?
Yeah, guys. I hope everyone is back. Maybe we just wait one more minute. So 11:32, we will start. It's 11:32. Maybe we just few seconds.
Yeah, sure, Ramesh. We'll start in a minute.
Okay, let's get started. I hope most of the guys are back.
Okay, awesome. So just give me a few seconds. I'm just closing a couple of things on my system. I just feel like it's a bit lagging. I think I have some compilers running. Just trying to find out what is it. What's that? Okay, so welcome back, everyone. So I hope I'm not boring anyone over here. So if it's boring, please back. So the main goal is to ensure everyone takes away the concept of reactive when they step out of the session, right? So we may be dwelling a bit deep, or spending too much time on one particular thing, but that is in the hope of the greater good. So coming back, right? So observables. So if you sort of see, or let me just come back to another slide. So let me come back to this slide, right? So so if we take this, right, if you see, this is a stream, right? So this stream is what we call an observable, right? So, and if we are listening to the stream, right, or the process of listening to the stream is what is called subscribing, right? So when you subscribe to the stream, it means you're listening to the stream, right? If any changes happens, you're going to get it. Consider it more or less like a newspaper subscription, right? So if there is a newspaper vendor, right, you going and purchasing a newspaper from the vendor for 5 rupees, right? So that is like a promise. You give the newspaper vendor 5 rupees. He promises you he'll give you a newspaper and he gives it to you. This is a one-time transaction, right? This is a promise, right? But consider uh, every time there is an updated newspaper available, you want it to be delivered to you, right? So you go and tell the vendor, see, I need to subscribe, right? I need a subscription. And you say, this is my address. This is the edition I want. I want the Hindu or whatever. And you give him the form. And what he says is, okay, I will start. If I get an updated newspaper edition, I will send it to your address. So multiple people can do this thing, right? A promise is one thing. You go give a guy 5 rupees, you get a newspaper. This is a one time. Another person wants a newspaper, he has to come give 5 rupees and he has to get a newspaper and he has to go, right? So it's a one-off transaction, but a subscription is not so, right? So the newspaper vendor, multiple people can come and subscribe, and every time there's an updated copy, every one of those people get an updated copy, right? So if you take it in that format, right? So what we are having over here is a subscription, right? So I mean, when you're listening to the stream, so essentially over here, we are listening to the newspaper vendor, right? So every time there's an update, so probably it's everyday morning for us, right? It's a routine thing. So, but consider that as a stream, right? As a stream where every day you get a newspaper, right? So essentially, once you subscribe to the vendor, every day morning is going to come and give you a newspaper. Essentially, there is a stream. Newspaper is the data that comes in, and you listening to that stream, right, is subscribing, right? So the main terms that we have to undertake, or we will commonly use when dealing with streams in terms of syntax, right? When implementing RxJS in our day-to-day code basis. Observables, that is the stream. Subscribers or subscription, that is the listener, whoever is listening to the stream. And then there is something known as an observer, right? An observer is someone who acts on it, who acts on the subscribed data, right? So once you get a data, so that is essentially going to be a function for us, right? Once you subscribe to something, you have a function that handles the data whichever you got from the stream. So essentially, you would be the observer. When we take the newspaper example, you would be the observer because you're the function, and what you do is you read the data, right? And you process it and you take value out of it, right? So another thing that you have to understand is, sorry, I left out one thing. Just 1 minute. Yeah, I'm just looking at my notes for the slide. And this stream, right, that is the observable, is also called as the subject, right? So the stream is also called as the subject. So one thing you have to note is you can literally change anything into a stream, right? So it can be a variable, it can be a user input, it can be some data structure, an array, or anything, right? You can literally change it into a stream, and then once it's a stream, then it becomes a subject, right? So if it's a subject, then you can subscribe to it, and it becomes a pub-sub relationship over there. So I think I introduced quite a bit of terminologies over here. So what I'll do is I'll just recap, right? So this timeline that we are seeing is what we call a stream, right? So this is a conveyor belt, right? So, and these marbles, I'm sorry, I'm not coming to the marbles over here. And this stream carries data, right? So this stream, when we are dealing with in terms of code, we can call it as a subject or an observable, right? So both are more or less the same thing, a subject or observable. You can call it a subject or you can call it an observable. Anything listening to the stream is called a subscriber, or it is subscribe to the stream, right? Or a subscribe to the observable. And something that acts on the subscription is called an observer, right? So subject, observable, subscriber or subscription, and observer, right? So these are important terms we need to keep in mind as we move forward, right? And you can more or less create a stream out of anything, right? So that is another thing. And once we have a stream, right, or an observable, RxJS provides us with a numerous amount of operators that we can use to act on the data, right, in the stream, right? You don't have to subscribe. Without subscribing to it, you can actually act on the data in the stream before you actually send it off to a subscriber, right? So let this sink in, right? So I'll just give it a few seconds. If you didn't understand anything over here, please feel free to ask now. Or one thing I can do is, let me just sort of write it over here. Oh, I have something. Okay, this is, just close these. Close this. Okay, okay. Okay, so we have a subject or observable, which is the stream, right? And then we have the subscription or subscriber, right? Listening to the stream. Then we have the observer who acts on the subscription. If I can increase the size of this. Yes. Okay. So does anybody have any queries over here on this? Okay, I'll move on. So since we have this, right? So I told something, right? So I told that once you have a stream, right? RxJS provides operators, right? That can act on the stream, right? So to understand this, right? Let's come back to the newspaper example, right? So I'm not sure how many of you are buying newspapers nowadays, but if you notice, right, the newspaper company gives only the newspaper, right? These vendors, at times what they do is they slide in an advertisement paper within the newspaper, right? And they throw it to you. So this particular act, right, of sliding an ad into the newspaper, right, is an operation, right? Is an operation performed by the newspaper agent, right? Right. So essentially, if you see, this is an operation. So basically what the newspaper agent does is, he receives the data from the newspaper company, or the stream actually originates from the newspaper company, right? They send out the data. The vendor over here, he acts on it. What he does is, he takes in, he does not subscribe to the newspaper, right? What he does is, he takes the newspaper, he makes some modification to the newspaper, that is, insert an ad flyer into the newspaper, and then he ships it off to you, to the subscriber, to you, right? So if you see, this is an operation he performs. He is transforming the data in some way, right? So RxJS have the capacity to do this as well, right? So when there is a stream, right, you can use operators to transform data and then deliver to subscribers, right? So, okay. So yeah. So if there is a stream, or if there is an observable, what we can do is, in RxJS, we can use operators to transform data, not just to transform, right? You can just simply even read the data, but you don't have to subscribe to it. Without subscribing, you can actually act on the data and then send in a new stream. You'll be creating new streams. Streams are immutable, right? Streams are immutable. Streams, you cannot modify a stream, right? So every time you operate on a, every time you operate on a stream, a new stream is created. But the existing stream is untouched. We'll come to this again, right? But the concept is, the reason is because, let me put it this way, right? So for example, we have a data that is coming from an API, right? So let's take the shopping cart data itself. So let's just say the cart API gives a set of items and the price of all the items that is there. Now the subtotal component, right? What it does is, it tallies up all the price of the items along with the taxes and everything, and it displays the subtotal, right? Now the thing is, we can't simply go and introduce the subtotal into the mainstream. The reason is because the shopping cart component and the number of items in the cart component that is at the top right, these two, maybe just for visualization, if someone is lost, let me just open Amazon over here, just for picturization. Okay, we have a cart. So if you see, this shopping cart, this does not require, okay, the subtotal is actually displayed over here, but just consider there's no subtotal over here, right? The subtotal is only over here. So this does not require subtotal, right? So it wouldn't make sense for me to, tally up the subtotal and put it into the data, right? And send it to both these things, because it doesn't need them. So what I can do is, I can create a stream separately that will go to the subtotal, but the original stream will be untouched. So the shopping cart component and this number of items in the cart component will receive the original stream, whereas the subtotal component will have a transformed data. That could be happening in the subtotal component itself, right? It will not be happening elsewhere. It can happen in the subtotal component or the subtotal component service or whatever we have. I hope I still have everybody in the loop. Is anybody lost? Is anybody, not getting a grasp? Please tell me. We can take a step back, revisit, and then move forward. Okay, I'll take that as everybody is doing fine. So we'll come back to our observables over here, right? So, okay. Okay. So, oh, we are almost at 12. Okay. So we'll take a look into some code, right? Okay. So we saw observables, right? So let's just look at a bit of code over here, and so this is okay. Okay. So we said we talked about observable, we talked about subscriber, and we talked about observer, right? So an observer is someone who acts on the data, right? So, but what does he get? What does he get to act on, or how does he act, right? So let's just take a simple example, right? Let's actually declare an observer, right? So let's just say, const observer. So let's just say this guy is an observer, right? So potential things that an observer can act on, right? So as if we come back to this slide over here, right? So we see that there are three things that the stream provides, right? We can act on. So one is a value, right? So this we can actually call it, next, right? The reason is because we would always have, to say, once I have the data, what do I do next, right? So I pass it somewhere else. So that is why we call it next, right? So this is a standard analogy over here. So this is a standard format that is followed when creating observers. So let's just take Amazon itself over here, right? Let's just take, there will be, our conveyor belt is that. So we are getting a lot of items on our conveyor belt, that is the data. So let's just say we get a package, right? Or let's just say an item, right? So what we can say is, we can say console.log of item is being shipped, right? So, or if we want to, we can just say item over here, right? So I haven't made this into a TS file, so I'm not getting any syntax highlighting and stuff, but we'll get to it, right? So is this font size fine for everyone? If anybody is not able to view it, let me know. I'm just increasing.
Clear.
Okay, cool. So next we have an error, right? So we capture the value over here. So when we say next, this item is the value that we get, and we process this item, right? And then there is an error. So similarly, we get the error and we say console.log, and something happened, right? Something went wrong. And I'll say $of error, right? And then complete. So the stream is complete. So most probably this is just going to be like, just, hey, it's complete. You're not going to get any data or something over here. It is just going to say, I don't have any more data to give you. You can actually close or you can unsubscribe over here, right? So we'll have this as an empty thing over here. We'll say console.log, and consider the observer is actually the person packing stuff, right? They may have to do things like pack the item, they may have to label the item, and all these things, right? So let's just say if there is nothing on the conveyor, this person can go. I mean, his job is done, right? He can literally just say, okay, my duty is complete, I can leave. So what we can say is, we can say no items to ship. You can retire for the day, right? So as simple as that. So once it's complete, you can say there's nothing to do. You can go home. Something like that. So this is an observer. Now we have defined an observer, right? So consider this as the person who is checking the items on a conveyor belt, right? So what he does is, once he receives an item, he processes it. He says item is being shipped. If there is an error, right, the item is not the proper item that was supposed to be going out for the shipment, or the item is damaged, or something else goes wrong, he will say something went wrong, and he'll say whatever that issue is, right? And if it's complete, the stream is not going to provide anything. It's just going to say it's complete, and he is going to like just walk away from the conveyor. He's unsubscribing. That is all, right? So now what we want to do is we want to create the stream, right? Now we have the observer. Now what we want to say is we need a stream over here. So what we can do is we can say const. So since we are calling this item, we'll call this as the items stream, right? Or we'll just keep it as the item stream itself, whichever works. So now I'll say new observable. So observable is something, oh, we haven't, or we don't have this. Let me actually save this and get RxJS over here. Spaces, create a new one, and let's say CFG. I think it should be good. So we'll just take this as observable.ts. Right? And okay, we got all the amazing things over here. Just fire up my terminal. Workspaces, we'll go to CFG. We'll I hope I have TypeScript installed. Yes, I have it. So let's just say psc net. Okay, that is just to get the ps config file. I don't want to go creating the ps config file by myself. And then we need Reactive.js. So we need RxJS, right? So let's just say npm install RxJS. This will create the package.json for me, and it would give the the basic things for me to run this, right? I don't want too much stuff over it. So in my node modules, if you see, I have my RxJS, and if I go to my RxJS, I have all the files over here. And if I go to my operators is what I'll be primarily using, right? See, I only have a package.json, and this basically just, sort of says where everything is. So basically, everything is in the dist folder over here. So if you go into the dist, you will have everything. In types, I think this is just going to export it. Internally, you'll have it. So if you see all these things, all the operators. So if you see, we have observable over here, right? So let's actually take it and use it, right? So the folder, and yep. So just as we go, let's just ensure. What is this? Sorry. This thing has any. Okay, that is fine. We'll live with it for now. So let's just see if CSC works. It's going to okay, let's just say let's declare it as a right. And error is going to be so right. And now I say CSC, and that I have observable.js, and I go and run my observable.js, and it's running. So just to make sure it's running, let's just sort of use the lazy way of testing things. We need to recompile. So yep, it's working, right? So we have this. So now what I can do is I can go ahead and create my item observable that I was doing. So I can say new observable. So yep, this is not willing to. I'm actually doing thing. I'll just take this to my website so that CFG. Let's just look at CFG. This project. Okay. So I am observable the PS. Okay. Oh, right. I think going into presentation mode would be much more helpful over here. Yep. Is this actually better? Do I need to increase the font size more?
Better, maybe a little bit, Dinesh. Just the control plus, it's not working for you.
Yeah, I think I have a different key binding enabled over here. No
Okay.
problem. You can actually increase it. This is very happy, but yeah, I hope it is much better now.
Yeah, better, much better. Yeah.
Okay, so now let's actually get back. So let's say item observable is equal to new observable. So if you see, I don't have the autocomplete stuff set up for VS Code, so I just came over here just to make things faster so that I don't have to be going and typing everything. So now when we say new observable, right? So this is one way of creating a stream by yourself, right? So now what we are saying is we now when we say new observable, a stream is created, right? So now we need to pass the observer or to say we need to pass the data to the observer, right? So but we already have an observer, right? So we have an observer over here. So sorry, this guy would actually be an input. Oh, sorry, is it on replace? Right? So we are creating, we say item observer. So what we do is the observable always, or we have to subscribe to an observer, as I said, right? So that is a stream, that is the observable. We subscribe to the observable, and then the observer acts on the subscribed observable, right? So now we are just creating a new observable over here. We are creating a new stream, right? So the stream will take in an observer and it will give the data to the observer. So what we'll do is in the stream, we'll have new items, right? So we'll say item observer dot next. So every time a new package comes up, I'm going to say dot next of, let me call something over here, right? So let's say phone X, right? So let's say we have another item that is to be shipped, and say that is going to be book Y, right? And once that is done, we can have even more if we want. So let's just say someone else ordered some any other item, cosmetic Z, right? So we can consider this as so. Oh, it's phone X. So let me just add an IO over here. It becomes an iPhone 10. And instead of book way, let's just say Alice in Wonderland. And instead of cosmetics, let's just say I'll go for the classic vocal sample. So it's a vocal sample code, right? So we have these things. There are 3 shipments that are going out. And once this is done, I can say complete, right? So I'm actually simulating a stream over here. So what I'm saying is I'm creating a new stream, and in that stream, I'm saying there is an iPhone 10 item that is going on. So this is basically the conveyor belt. There is a conveyor belt. I'm placing the iPhone X on the conveyor belt. I'm placing an Alice in Wonderland book on the conveyor belt, and I'm placing a vocal sample powder on the conveyor belt, right? So The next thing we would want to do is we would want to subscribe to it. Am I correct? So we would call it as item observable subscription. But okay, let's actually go for that. Item observable subscription, right? If it is too long, let's just cut it out with some, right? And then if you see, we have the observable over here, right? So what we can say is item observable. So the stream and subscribe. So I'm subscribed. So now I'm subscribed, right? But what do I do? What do I do? I am subscribed. I'm getting the data. But what do I do, right? So this is where we bring in our observer. So we say observer. So essentially, now what would happen is, now that we are subscribed, every time. So every time this calls next, what would happen is our observer would act on it. So it would say next. So dot next. So we are actually passing our observer. So our observer will come over here and observer dot next iPhone X. So it will come over here and say iPhone X is being shipped, right? And Alice in Wonderland is being shipped. And once the complete is called, it will say no items to ship. You can retire for the day, right? So let's actually do one thing. Let's come back to our code. Let's see it. Let's node observable.js. So if you see, we have it. So iPhone X is being shipped, Alice in Wonderland is being shipped, Vocal Santal is being shipped. No items to ship, you can retire for the day. So in code, so far what we saw was in picture, right? In a picture, we saw how an observable looks, how the data in an observable looks, and okay, we literally didn't see a visualization of the subscriber and the observer, but and subscriber would be listening to this. So once a subscriber gets a data, he would act on the data, right? So this is how it looks in code, right? So in code, there is an observer who performs three specific, or he handles three specific outcomes of a stream. That is the data or the value, then there is the error, and then there is the complete. So once all these are optional as well, right? You don't have to even specify these things, because there can be phases where you don't even get a value, right? So I mean, you do different things during those times. We'll see those situations later on. But once we have the observer, then there is a stream, and the stream passes the data that needs to be sent out. And once the stream is ready, we subscribe to the stream and we send the observer inside, right? So one thing is, this observer, you don't even have to declare it as a separate variable, right? So usually what happens is, in our subscription, we usually have it like this, right? So an observer is usually just passed as a parameter to the subscribe method. As you see, our observable class over here, right? It just takes, I mean, an instance of it just takes this as a input only, right? It takes as an input parameter over here. So you can actually pass it directly. You don't even have to have a variable over here. So this can be, even shorter over here, right? So in essence, this is how it works, right? But once the complete is called, if you call the complete method over here, the stream would unsubscribe itself, right? You don't have to worry about anything. But if the stream is not calling complete, then in that case, you will have to unsubscribe by yourself, right? So unsubscription, we'll come to it a bit later, right? Fine. If you have any questions or anything around this, you can feel free to ask me. If you didn't get any part of it, what is an observable? What is a subscriber? What is an observer? Even if you think something is silly, just pour it out, right? Better to get it clarified than to have it as a doubt within itself.
I have a question.
Yes, Saranya.
Okay, the thing is that when it encounters an error, what happens? Does the observer gets completed?
No. So there are a few things we can do, right? So usually when an error occurs, there are two things you can do. One is you can handle the error. The thing is, there are two methods that are commonly known as catch and throw or catch and replace, right? So catch and throw is you catch an error and you throw it back in the stream, right? So that the next person, whoever is subscribing to the stream, can handle it, right? Or what you can do is you can catch the error and you can replace it with another observable, right? So one example could be, let's just say, uh, you're expecting a list of items from an API, right? But the API is not able, something happened, right? And it gives an error saying 404 data not 4. Now you have an error over here. So what do you do? So you can do two things. You can catch that 404, you can throw it back into the stream. So you're catching it from the source stream and you're throwing it into the stream again so that the next person whoever is subscribing can handle it however they want to. Another thing you can do is you can catch that error and you can replace it with another observable. So basically what 404 means, thing is not found. What you can do is instead of showing the user an error screen, you can actually show an empty list of items and you can show a notification or something stating there are no items to show or we couldn't find what you're searching for. So what you can do is you can replace that observable, that errored observable with another observable, right? We'll see more about errors as we go forward.
Okay, thank you, Thomas.
But for now, let's just look at the happy scenario, right? Happy scenario wherein no error occurs, the data comes, the data is good, the observer is acting on the data, everything is working fine. But just to demonstrate, all right, let's just take this over here. Return that observer dot error. Item is damaged. Right, let's do that. Let's see what happens. So not global database. I actually gave it at the end, didn't I? But if you see it didn't complete, you notice the complete is not called. It errored, so it just broke off, right? And say if this is going to happen just after this, right? So I think what I can do is I can just get the commands together since I'm just using it frequently, and let's do that. So if you see, just right after iPhone X, my thing got broken up, right? So the default behavior is when an error occurs in the stream just breaks off. It unsubscribes and it cancels everything after it, right? But this can be handled. So what we can do is we can handle it much more better over here. So when we receive an error, rather than sort of handling it in this way, we can replace it with a successful stream, right? So, but we'll see that as we go forward. I don't want to confuse by bringing in operators at this space at this moment. Okay, so considering there is no questions, I'll actually move forward, right? So we actually saw this observer over here, right? We can further simplify this down, right? So if I just take this piece of code and put it over here, let me just call this just 0, right? So I can say I can subscribe multiple times to one observable, right? So this is not wrong. This is totally fine, right? What I can say is I can actually tell over here or this thing. I can just take this and I can put it. I don't even have to say next error and this stuff over here, right? I can just take it and I can put it over here. And similarly, I can do for error and I can do for complete. If you see, it's automatically detecting next error and complete. If you see WebStorm suggestions, right? So that is basically the type that is available for subscribe, and based on the type, it is defining the parameters over here. So if you see, this is also going to work just fine, right? This is not going to have any issues. So let me actually remove this over there. And if I go back to my thing and run it. So if you see, the second one also is running over here, right? So it's subscribed and it's running. If you want to confirm, you can actually run that again. You see, we are still having it. So this is also just running fine. So this is further simplified down to this, right? So now coming back, so to unsubscription, right? So back to this. So it is very critical. You have to unsubscribe. So when you say unsubscribe, you're stopping the observable stream, right? So right. So it is very necessary that you have to stop the observable stream. The reason is because memory, right? So if you are going to leave your stream open throughout the life cycle of your application, and if your application say, if your application is something like a stock market monitoring application, not sure how many of you are using something like Upstocks or something, but if you notice, usually when like day traders log into the application, they don't refresh the page, right? The page is there for hours on end through the day, right? Maybe for 2 hours, maybe for 3 hours, it may be for all through the 6 to 7 hours the market is online during that period of time, right? So what happens is a lot of data, especially in real-time applications, and a lot of data is being generated, and if the events are not being flushed out, or the data streams are not being flushed out appropriately, or being killed after they're being used, this is going to stack up on the memory of the system, right? And at some point, it's going to cause the application to crash. So this is something we call as a memory leak as well. So it is very vital that you handle the lifeline of your, or the lifespan of your observable as well. Once its purpose is not done, or its purpose has been met, you have to unsubscribe to it. There are certain conditions where the observable takes care of itself, right? So one thing is when it completes, right? So when the observable completes, it unsubscribes, right? So another thing is, so when I say observable complete, so I'm saying call complete, right? So when you call, so over here we are calling the complete method. So when you call this, the observable also terminates itself, right? It stops streaming, or the stream is cut off, right? The stream is killed right there. And there is also known as an operator for complete. So there may be times, when you subscribe to the data, you're not even at the origin, right? The data flows to you. From a subscription point, you may want to, cut off the stream, right? So there is a complete operator that can also do this job, wherein it can stop the stream. And as we saw, another thing is errors, right? So errors basically kill the stream as well, right? So if an error occurs, that also kills the stream, right? So throwing an error also kills the stream, and then calling unsubscribe. Okay. Unsubscribe. That's fine. Okay, fine. Oh, changed color. Wow. I don't know what I did over here. Yeah. Okay. So you see, these are methods by which a stream stops itself, or you stop the stream, right? So unsubscribe is something you may have commonly used. So usually what happens is, if we are in Angular, we would just go to ng on destroy, and we would say item observable dot unsubscribe, right? So You do this, right? You can also do this over here. I mean, but the thing is, this is asynchronous, so you don't know when this is going to execute over here at this point of time, right? So this is a very conflicting way to handle. You can't just put it right after the statement, right? The reason is because once the subscription is created, it's just going to destroy it because it's not going to wait for the observable to start streaming and all this stuff, right? So doesn't make sense to add it. So, but in Angular, ng on destroy executes only when the component's life is done, right? So this is safe, but this is how you use unsubscribe, right? And there are certain other ways to ease handling unsubscription in Angular, but we'll see about it. Or we may not see it during the session, but you can go and you can explore on it by yourself, right? So yep, this is unsubscribing or stopping the observable stream. Any questions over here? Okay, I'll take it as there's no questions. So we'll move forward. So now let's just exit away from this and let's go to StackBlitz. How many of you have actually used StackBlitz or using StackBlitz actively? If you haven't, this is an amazing piece of software. You have to try it out. So if you're doing any small POCs, if you're sort of getting your hands dirty with learning something new, this is really great, right? So if you see, I just have an application ready and running for me now, right? So this took literally about less than 30 seconds for me to get a base Angular application running, with all the packages installed and all this stuff. So let me just increase the size over here. Okay. I really wish they gave an option to just increase the font size. Maybe it does that. I've seen. Okay. Let me not dwell into that. So let's do one thing, right? So let's actually take one of my favorite open APIs that is available on the internet. So the Pokemon API. So how many of you actually know about Pokemon, and how many of you have heard of this Pokemon API? Anyone?
Me no. Guys.
Awesome, man. Okay, man. So for those who haven't heard of it, just go check it out, right? So this is a really great thing to use for learning, right? So if I'm just going to it's going to give me a list. I have a JSON plugin installed, so it's just giving me in a more formatted manner. You may not get it the same way, but you can install the JSON. I don't know what it's called. It's called the JSON Woo, right? The JSON Woo plugin. So let's do one thing. Let's actually sort of create a simple service. So let me just say service. I'm not going to be following a lot of folder structures or anything over here. So let me just call it Pokemon. So we have a Pokemon service over here. Let's just say get Pokemons, right? And this is going to return an observer. For now, I'll keep it as any. And we'll say return. We haven't imported this, so let's say private HTTP HTTP point. That in turn comes here. Let's just go to the module and check packets are imported over here. So we go here and say HTTP module. That should basically get our service up and running. And here we can say this dot HTTP dot get. So this will, oh, we don't have a type. This will be needed. So what I'll do is once I declare the type, I'll bring this over here. So until then, let's just do this and this, right? So this is literally, just going to generate an observable for me, and it's going to, give me the Pokemon data, right? So let me just providers, Pokemon service over here. Let me come back to my PS file. Let me add a constructor, and let me say private Pokemon service, foreign Pokemon service, right? So awesome. So we have a Pokemon service. So I can have NG on that. I would need to implement it. So elements net, and it should be automatically imported. Fine. So I'm just going to say okay. Just see if this is being used over here. Yes, it's going to. So let's just say I'm just checking if this is working, right? So the start name is equal to Pokemon. That's working. Okay, and this is working. So let's just say this dot Pokemon service dot get Pokemons dot subscribe, and let's say Pokemon tends to, right? And let's just list all our Pokemon one by one, right, in our console. So just say Pokemon, right? And let's open our console. So if you see, we have a response over here, right? So I set up a very simple, API that fetches some data and it displays. So this is a very common thing that we do. Am I right? So this is one of the common ways of how we create services. Call APIs, subscribe to them. This in turn itself is RxJS, right? So, but is it declarative, right? So from the definition we saw on Wikipedia, right? So from our previous slide, what we said was it's a declarative programming paradigm, right? So when we say declarative, what we mean is declaring variables, right? So am I actually declaring variables over here in order to read the stream? If you say no, right, this is actually a service. I'm just calling a function over here. So and this function in turn comes over here, it returns an observable and I'm subscribing to it. This is not what I want, right? So so when I say declarative, my stream should essentially be a variable, right? So when I say a variable, what do I mean, right? So essentially, my Pokemons should probably be something like this. So observables are something, we commonly, in order to denote it's an observable, we use the dollar term. This has just been a massively adopted thing. It is not mandatory that you have to do it, but considering this has been massively adopted, it is good you follow this pattern, right? So that other people are more comfortable as well. So what I could say is I could directly assign the observable over here, right? So drag and drop over here. Right? So if you see, this actually returns an observable form, right? This dot HTTP dot get of whatever. So this is, this is a declarative approach, right? And now if I go over here, would I be able to actually come to my component.ts, and instead of calling this get Pokemons, would I be just able to say Pokemons $.subscribe? This is working just fine. If you see, right? I'm just refreshing the page. This is working just fine, right? But let's do another thing, right? So for now, I'll revert this, right? So I'll have this as get Pokemons itself. What we'll do is we'll have this dot Pokemons. Oh, sorry, I gave this dot. Sorry, I'll say Pokemons colon any, right? And I'll say this dot Pokemons is equal to Pokemons. Oh, sorry, this is Pokemon. This essentially gives me back Pokemons, so it's supposed to be Pokemons. I'm not like having a singular thing. If you notice over here, it's listing out all the Pokemons from, right? It's one single thing over here. So I'll call this Pokemons itself. So let's print it over here. And what I'll do is I'll come back, I'll come to my HTML, and over here, I'll create a table, right? And in the table, I'll have t head, and I'll have, oops, yeah, okay. And I'll say ph, just name will do, I guess. And we'll have that alone for now, right? So I'll say body, and have another table row, and we'll say pd. Let's just say name also, right? And yeah, we would have to add that. So now what I would do is I would need to loop through my Pokemon's variable that I have. So let Pokemon of Pokemons, right? And this one would be Pokemon.name, right? So I just ensure that is the correct thing I have. So if you see name, okay. So okay, cannot find submitting object of object. What is the issue? Fine. Okay. So over here, if you see, we are getting an object over here, right? And probably it is not able to read, or the ng4 is not able to iterate through an object, right? So what we need to do is we need to say this one is Pokemons.result. And now we have everything working, but the reason this is not coming is because star df is equal to it's still not working. What could be the problem? Okay, it's the start Pokemon result. Okay, I think I'm making some mistake over here. It's results. Fine. Oh, sorry. Okay. Fine, got it. Okay, my bad. Okay, so if you see, I got my Pokemon names over here, right? So this is basically the first 20 that we are getting, right? We still haven't implemented the next and all this stuff. But if you see, I'm getting the names of the Pokemons over here, right? If I want the details of this Pokemon, those details are available in another URL, right? So let's actually do one thing. Let's display that URL as well. So I'll just create a duplicate of this, and I'll say URL, right? And this one, take it and say URL as well. And let's do one thing. Let's add some beautification stuff over here. And let's say cell. This is the right thing. So let's just say 10. Okay, we have something good. Okay. I'll come back over here and I'll say hello. What is the hello? Okay. Oh, this is the hello component. let's actually take this out. Let's convert it into a H1. Let's just say Pokédex, right? So fine. So if you see now, we have a simple table that has the name of the Pokemon along with the URL where we can view more details about it, right? And just for the fun of it, let's just make this right. So now we have a much more better, more pleasant UI over here. So now if you see, we are still using get Pokemons. What would happen if we go and replace this with our declarative approach? It says results does not exist on type object. Why? Okay. So, but if you see, we do have the data coming up over here, right? So the console.log is printing. We are having this, but we're getting an error. It says that, this thing does not exist, right? So when you're using a declarative approach, right, Angular gives you something known as an async pipe, right? So it's as simple as, so we have this over here. What we can say is that Pokemon of Pokemons, we can say async. Sorry, I think I'm using it wrong. This is when our documentation comes into help. So let's go to our angular.io. Let's just search for the async pipe. Okay, here is the async pipe. Okay, so you see, you give the object expression followed by, I guess I actually used it correctly, but just for the sake of it, I am just going to look at an implementation that they have done over here, right? So okay, here it is. So greeting with async. So if you see, greeting is actually a promise over here, and it is resolving that over here, right? So this is actually correct. So what I have. So let's actually go with this. So if you see, like Pokemon of Pokemons, we are just saying async. So okay, we are still not getting this. That is bad. I'm not sure why that is happening. Okay, we have that. Fine. Okay. So the mistake I did over here is I'm basically sort of subscribing over here. So what I'm doing is this dot Pokemons is any. This is not even an observable. And when I pass this inside an async pipe, it's not going to do anything, right? So essentially, we don't want that. So what we want is we want to assign this to Pokemons over here. So we would say this is equal to this, right? And this piece of code, we actually don't want it over here, right? So now if you see, okay, okay, now we have a totally different thing. We are in a different, error. So basically what is happening is the async pipe, I mean, ng_for is expecting an array over here, right? But then trying to parse an observable using an async pipe in ng_for is sort of making a complication, right? So that is practically not feasible. So that is an error from my end. So what we'll do is we'll just check how we are going to use the async pipe over here, right? So essentially, if you see, rather than using the async pipe over here, I actually have my conditional check at the top, right? So what I can do is, and another change. So just as I see Pokemons, I remember this is an observable now, right? So every observable is represented with $1, right? So let's change it to $1. So now I come back and over here, I say $, and now I pass this. So now this is an observable. Now I can pass it to the async pipe, right? Now this would process, right? But if you notice, okay, Okay, so if you notice, it's actually saying property Pokemons does not exist on type app component, right? So the Pokemons is referred to in this line 10, right? So the thing is, it is processing this, but what is happening is we should not be having a console log. The reason is because, yeah, but if I open this, right, let me clear this as well. But if you actually notice my network, I would be having a call that goes out, right? So let's just reload this and let's take a switch off. I don't actually see the call. Oh, sorry. This is actually this one's. I'm so sorry for messing this up. But if I open this in a new one over here, right, and if I actually open this, I should be able to see a call. It's not actually calling. Okay, I'll just get back to this, right? Maybe I'm making a mistake of whether it will call or not. So, but if you see, I have the async pipe over here, right? But if you see, it says this Pokemon's thing is not, available for it to work with. Oh God, I lost this. There it is. I'll just open it over here. So it just says that this Pokemon's property does not exist. So one thing I can do over here is I can actually say, in this observable, take it through the async pipe, and whatever output you get from the async pipe, just put it into this variable, right? So now if you see, I have something, right? So, but if you see, it's saying type object is not assignable to type NGI triple. So as soon as we see this NGI triple term, we know that this is something to do with NG4. And we know that Pokemon's return an object, right? It does not return an array. So what we need to do is we need to say Pokemon's dot results. Okay, this seems to be strange again. Okay, let's actually do one thing. Let's actually render our Pokemons as a JSON over here and see what is the result we are getting, right? So, what's this? I'm just coming back to the Angular documentation. So, okay, observer. Let's just take async. We don't have async pass over here. Okay, so let me just get to RSJS. I'm just making some simple mistake that is causing the issue. This is a different async. This doesn't support it. This is the one that has the async. Okay. Let me just come back and see if I have everything correct over here. This returns an observable from here, so we do get an observable over that. And Yeah.
Dinesh,
Yes, Sanjay.
can you use the pipe operator and filter using the map operator and filter the results in the service pipe? I
Yeah.
think it may
So
work.
that is one thing that we can do. So that is a good suggestion, right? So let's actually do that. So what we'll do is we are actually, running or getting the observable over here. So I said previously, right? It's like the newspaper vendor adding an ad flyer to you. So what we can do is we can pipe over here instead of subscribe, right? I say pipe, and what I can do is I can tap into this. So when I tap into a stream, I'm not going to make any changes. A tap operator is something like just reading from the stream, right? It doesn't make any changes to the stream. So I can say, some data over here, and I can just say console.log of data. And I would need to import this over here. So it's not controlling this. Okay, so let's just import tap from and do we have this? Now it's JS operator tap. Okay, let's just come over here and check if we are importing the tap properly. It's RFJS operators. It's supposed to work. Or you just import it from there. You don't specify that. Okay. So now if you open up console, we're not getting this. Okay.
In service file, Dinesh, we can use this pipe operator, right?
Yeah, in the servers also we can use it. But the thing is, the stream should just sort of follow up over here as well, right? So I'm just thinking.
We can use the map operator. We can use map operator and just return the results.
Yeah, but are we getting the data? That is what I'm looking at. Just 1 minute. Tap from to slash, right? So okay. Okay, so just take, so we'll map it, we'll take the data, and return data results. This this is because of this. Okay. Fine, awesome. Thank you, man. Was it who was the one who suggested?
Yes.
My bad. So So yeah, so this was the issue, right? So we are basically getting the data, but then getting the data, we should, I mean, the tap operator should be working here. I'm not sure why the tap operator didn't come pitch in over here. We'll look into that as well, right? So if you see now, but then we'll talk a bit about operators over here then, since we came with the pipe, right? So if you see operators, right? So essentially, if you see, we are not even subscribing. So this is an observable, or this is a stream. This is, it turns a stream, and you know, every time we are going to hit the API, right? A packet of data is going to be sent out on the stream. So before the data is actually sent to the subscriber, we can perform a set of operations on the data, right? So consider the same thing, a conveyor belt, right? So when the data is rolling out on the conveyor belt, we can, you know, put in operators to perform certain things. So for example, let's just say every item should be sanitized, right? So what we can do is we can put in a sanitize operator. So that is basically a bot, right? So with an arm, right? So what we would do is every product that comes, it is just going to spray sanitizer on it, right? And let's just say there is another operator. What it does is it takes the product and it you know, sorts of adds a price tag to it, right? So all these things can be operators, but you have to understand there are some things or some rules that don't apply that would in reality. So in reality, you cannot simply go and say a conveyor belt or that particular stream is immutable. But when it comes to RxJS, that is possible. So every time you perform an operation, right? So for example, you perform a map operation over here. What happens is this creates a new observable, right? So I guess
Dinesh, we have sorry to interrupt. So we have around 8 minutes more than the scheduled time. You can.
Yes, sure. So if you see the marble diagram represented over here, right? So you see there is item 1, item 2, and item 3 coming, right? And what we do is we perform a map operation. So if you see, this stream will remain a constant. It will not change. It will be same. Any other subscribers to the stream will receive this 1, 2, 3, right? But when we perform the map operation over here, what we do is we create a new stream over here, right? So if you see, what we do is every item we multiply it by 10. So item 1 becomes 10, item 2 becomes 20 items, item 3 becomes 30 items. So essentially, anybody subscribing after this, right? So they will get this new stream. They will not get this old stream. So essentially, you can say for places, so the same place, let's just say that, you know, I don't want this to be happening over here. The reason is because you know, potentially this Pokemon service can be used for other purposes in other components. What I can do is I can come and simply put in my map operator over here, right? So this is expecting a comma, and this is going to expect map operator. So if you see, this works. So essentially, my Pokemon service stream is now untouched, right? But the stream that is created over here in my Pokemon component is changed, right? So this has only the results now, right? So another simple thing is, you know, I would just return data over here, and I could also just sort of come to my thing and over here say dot results. This would also work, right? So the reason I would do this is, say I want to load the next page, right? So how do I do that? That would be a question. So if I have it like this, I can probably say over here, hey, href is equal to next page. And let's just take this as button. I think that would be better. So next. Right, and on click we would call say a next page function that says Pokemons dot next, right? And if we actually go create this button over here, sorry, the function over here, and call it. Oh, okay. Oh, this actually exists only within the T body, right? So this is actually some issues. So we can actually put this within the entire table itself, right? So now if you see this will work, and I will have an X button. If I click on it, show why the console.log is not working. Okay, I feel there is a problem with the console.log over here, or maybe the console.log is firing it over here. So, but yeah, but you get the point, right? So, based on, so, okay, the console log is working now. Okay. Now the tap operator is working as well. This seemed to be a bug on Stack Blitz. So sorry about that. We spent too much time on this tap operator and map operator. But you see the point, right? So you see the point of how we can actually work with the data over here. So if I actually come back to my index.html, so I think this is fine. So we have the async operator that resolves the observable for us and gives it as a Pokemon variable, and inside this table we will be able to use it, right? And if you see component in component.ts, we don't need to listen in to or subscribe to our observable from the service. So, and this function is more or less not needed. So if you see our and even this tap I can remove, right? So I don't need a tap operator over there. So now this observable as simple as this, right? So it is just a simple declarative, or a variable that is declared for me, observable over here. This is my service. I can have plenty of other things that goes on over here, like Pokemon, right? Other APIs also will be just variables declared over here. So and even over here, when it comes, I would just have variables declared as observables, and these would be just streams that are being passed from the service, right? So and when I'm using the async pipe, another advantage is async automatically takes care of unsubscribing the thing for me, right? The observable. We have 2 minutes left, so I'll just take about another 10 minutes just to recap and give some space for any question or answers that we may want to discuss about. And I'll take about 3 minutes now just to give you a heads up on where to go next, right? Now, since you know the basic concepts and all this stuff, where to go next? How do you improve yourself in reactive programming, right? So, so yeah, but I think this itself shows the amount of efficiency in terms of code that we are creating over here, right? So instead of having to handle subscriptions, deal with data and all this stuff. I mean, in a subscription, sometimes if you see, we'll have subscriptions inside subscriptions, right? So that will become like it will become like a callback loop that callback hell that we don't want to get into. But to say in precise, what you have to be more aware of is ensuring your components are listening, right? So if you see over here, I'm not what to say or my Pokemon component is essentially listening for data over here, right? So anytime Pokemon service is going to get an update or something, this is automatically just going to sort of reflect over here, right? So any change, even in the Pokemon service, if I make any change over here, say I want to add a new thing like a serial number or something over here, and I go and map it and I add it, this is automatically going to reflect for me over here as well, right? It's going to come as part of the stream. So the biggest power, so I think you now understand how to create an observable, how to subscribe to an observable using the async pipe, and how to do small operations on an observable, right? So the next things you would have to go into is other powerful operators, right? So, okay. So if you see, if you just come to this rxjs.dev, right? So let me just come from the homepage, and if you click on this reference link, right? So this is going to show you a list of all the operators. So there are so many operators available, but you don't have to use all of them, right? And don't sort of feel like, how am I even going to learn all these things? You don't have to, right? So the thing is, you learn on a need basis. That is all, right? So what you have to do is, there are a few things that you would use on a day-to-day basis. So something like the tap operator, which is very useful for debugging. Something like the map operator, which helps you map a response to a different format, or just return the data as is to the stream, right? And a few other operators that you would want to frequent is combine latest. Then there are the merge operators that you want to look at. So the merge operator, then the merge map operator, then what other thing? The debones operator that I think it was Karthik who talked about this. So debones operator. So and then distinct until changed. That also we saw distinct until changed. And then you also have a few other things like switch map, right? So switch map are all interesting use cases. So like we are running out of time, so I'm not able to put in a bit of extra stuff over here that I want to go through. But let's just take it. Okay. I think, okay, we saw RxJS and Angular. It was a very preliminary thing. We just saw a basic implementation of one API and how do we, subscribe to it using an async pipe, right? And we saw a basic piping our streams. So piping our streams is essentially, using the, sorry, I opened the wrong one over here. So this is what I mean by piping a streams, right? So this is a stream. This Pokemon is a stream. I'm essentially just piping in order to, perform some operations on the stream, right? So then we have the async pipe that we already saw. Then error handling, we didn't look into it. But I'll just give you, the operators that, I'm sorry, I think Ramesh, can you just make me the host? I sort of clicked stop sharing by mistake.
Yeah, 1 second. Yeah, thanks. Now you're host.
Yeah, thank you. Ramesh, you just try giving the host option to the other Dinesh. This one is for the audio.
Okay, I think this, I did a mistake. Now I can't change. Okay, can you go there and change it yourself?
Sorry, I didn't get you.
No, it's, I think now I can't change. So
you can. Okay.
Arctic is coming to SQS in phase.
No, you said the same Dinesh back. Let me see if I cannot make a person host.
It's because the profile picture is same.
Yeah, sorry. Yeah, okay. We got the right one now. Okay, so sorry. So if you see, right, so is my screen visible? Yeah. So if you see, if you search for this catch error, right? So this operator is what we use to handle errors, right? So essentially what would happen is, if an error occurs, you can actually catch it and then you can sort of mend them, right? So this is basically two streams that we are having. One stream broke. We are catching the error and we are just, patching it with the other stream, and we are creating a new stream over here, right? So there are examples given as well. So I would urge you to, sort of write these examples by yourself, fidget with them, right? Don't just recreate what is here and leave it there. Try changing these things, right? Try adding an interval and see what happens. Try throwing different kinds of errors to see how it is being handled. Try putting it into your real world application, right? You may be already working on a project or something in your company or somewhere. Try just, creating a dummy branch. Try making a particular, a data flow reactive. Don't change the entire component. Just try changing one part of the data flow reactive, right? And see how you're able to do it, right? And see how efficient it is in terms of building on top of that, right? So this is more about error handling, right? And yep, so that would be it. And if you have any questions, you can actually ask now.
Chris, do you have any clarification? Okay, so if we don't have any points to clarify, then let's wind up the session. So we have we already announced, so we have the giveaway. So we have the 5 license to do. So yeah, so post this, we will just announce the winners on our Telegram. Telegram front end group base. So thanks a lot for everyone to join with us on this Saturday, and hope to meet you next month with another interesting session. Okay, thank you guys.
So if I can just give a thanks as well, Ramesh. So thank you so much for patiently putting up through these 3 hours. It was really great. And as I said, I am also just exploring Reactive Angular just for about the past 3 to 4 months, and it has been really great, to dive deep into Reactive Angular. So even in our company, currently we are revamping certain parts of the code, and we are leveraging Reactive Angular, wherever it would be possible for us to do so. As I said, since it's a way of thinking, you can only improve it on practice, right? So just ensure you are constantly practicing on thinking, right? Not writing code, but thinking about reactive, right? So how can I reactively rebuild the solution? That is this problem that is already existing. How can I reactively approach it, right? So your thought process is what matters most over here, right? So more than your skill to code, your skill to think is what matters, or your way of thinking is what matters. So it's more about ensuring the components are listening rather than asking for data, right? So I'm currently active on these specific social links. So if you want to follow me, if you want to get in touch with me, please feel free to follow, or just drop me a message on Twitter or Telegram, and I'll be happy to chat. And thank you. So
yeah, thank you, Dinesh, for the wonderful session. And again, Dinesh will be active on our Telegram group, so please feel free to reach him at any time if you have any clarifications.
awesome.
Okay,
Bye
guys.
everyone. Have a great Saturday.
Bye. Thanks, Dinesh. Bye, everyone.